Hope testing wasn't too bad for you guys. I just decided to do this little short video because I know the test is coming up. In case you have any questions, let me know. I only chose 2 problems to do. Let me know if there are any others. Just send me an email and I can try to work those out and help you guys out. So this one is from the practice the combined gas law. I'm going to go over number 2. A gas takes up 17 liters with pressure of 2.3 atmospheres and a temp of 25 degrees Celsius. If you were to raise the temperature to 350 K and lower the pressure to 1.5 atm, what would be the new volume of the gas? So here, this is your combined gas law. You have to rearrange it to have the variable that you're looking for by itself. But in order to be able to do that, we have to go through here and figure out what it is that we have. So a gas takes up 17 liters. Okay, so that 17 liters is going to be our initial volume. So V1. Now, with pressure of 2.3 atmospheres. So that's going to be our P1. Then a temperature of 25 degrees Celsius. So that would be our T1. Remember, the only thing here is you have to make sure you switch this to Kelvin. So that will be 25 plus 273.15, which is 298.15 Kelvin. Let's keep going and see what else we have. If you raise the temperature, so you're raising it to this, so that's your final. So that's T2. And lower the pressure to this. Ooh, that's hard to see. So we're lowering the pressure to this. So that's going to be our P2. What is the new volume? So they're asking us for new volume. So what does that mean? We're looking for V2. So typically I would have you just try to rearrange the formula. This one gets tricky, and that's why I included the screenshot in the Google Doc. Hint, hint, I would include these on your study guide for the test. So that way you don't have to rearrange them unless you feel like you can figure it out quickly, then go for it. So if you look at the Google Doc, right, and I'm looking at the rearranged formulas, the one for V2 is equal to P1 T2 V1 over P2 T1. The 2's and the 1's, the order doesn't matter. It's just if you were to do the calculations or the rearranging, that's how they would look. So all we have to do is plug them in. So P1 T2 and V1 divided by P2 and T1. If you were to take a look at all of the units, right, you can tell these cancel, the kelvins cancel, and we're left with liters, which is what we want because we're dealing with volume here. So you just have to calculate in your calculator, obviously, 2.3 times 350 times 17 divided by 1.5 times 298.15, and you get 30.5998, blah blah blah. We're going to round to 2 numbers after, so 60 liters. So that's your new volume. Okay, that's what you should have gotten for number 2 for the combined gas law practice. If there's any others, again, that you would like me to go over, please let me know, email me, and then I'll do another little short video, or at least a worked out problem. Alright, and moving on to Unit 5 study guide. I'm going to do number 1 with you guys, or on here, I guess, for you guys. Alright, a gas occupies 2.0 liters at 0.80 atmospheres. It is compressed to 4.0 liters and expanded to that. What is the final pressure? So here we have to realize is where there's a lot happening. So first they're telling you a gas occupies this at this pressure. So let's write that down real quick. So here, 12.0 liters. Because of the liters, we know that's volume. And because that's where we're starting off, it should be our initial volume. So 12.0 liters. Then we have 0.80 ATM. We know that ATM atmospheres is a pressure unit, so that should be our P1. And it says it is compressed to that and then expanded to that. So we have 2 more volumes. What is the final pressure? So what we're going to have to do is, because our pressure is going to be changing when it's compressed and expanded with those different volumes, we're going to have to solve these in a couple steps. So again, this does come off to be like a multi-step problem. However, since it is just pressure and volume and everything else seems to stay constant, right? Nothing else is changing. They're not telling you something about temperature or anything like that. You can do 2 things. So you can do 2 steps, okay? Or you can go straight to the end. If you're starting off with 12.0 liters and 0.80 atmospheres, you can use this final volume right here to find your pressure if you don't want to have to be dealing with this 4.0 liters. I'll do both ways. You decide what makes sense for you. So if I'm doing it the multi-step way, right, my V2 would be 4.0 liters, and I'm looking for P2. Because of the variables we're given and the units, we know this is Boyle's law. We need to look for P2. So if we rearrange the formula, we have this, which means we have 0, um, 4.0 liters, and that gives us let me see, 2.4 atmospheres. Since this is my P2, right? I can say my P2 is 2.4 atmospheres, and now we're going from these two to something with the volume. You could say the third volume of 10.0 liters. And we don't know what our pressure is. Again, we plug in, we look for P3, so that's going to be 2.4 atmospheres times 4.0 liters divided by 10. We get 0.96 atmospheres as our final pressure. That honestly seems like a lot. So if you want to do a shortcut way, this is the shortcut way. Again, we're starting off with these two and we're going to 10.0 liters. So we can literally have this be our formula, P3, V3. So we can do and we would you'll literally get the same thing. PA3 is equal to 0.96 ATM. You just have to be careful that here they're not telling you that there's constant change in temperature or constant change in moles or anything like that. It has to be just your units here. Again, let me know if you have any other questions, and I can work out those problems or do another short review. Do your best. You got this. You guys will do great on the test. Let me know if you have questions, and I hope you have a good day.